ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಮ್ಮ ಕಳೆದ ವಿಡಿಯೋದಲ್ಲಿ ಫಾರ್ಮೇಷನ್ ಆಫ್ PDE ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಹೌ ಟು ಫಾರ್ ಎ PDE ಫ್ರಮ್ ದಿ ಗಿವನ್ ಈಕ್ವೇಷನ್ ಬೈ ಎಲಿಮಿನೇಟಿಂಗ್ ಆರ್ಬಿಟ್ರರಿ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಆ್ಯಂಡ್ ಫಂಕ್ಷನ್ಸ್. ಸೊ ಎಲಿಮಿನೇಷನ್ ಆಫ್ ಫಂಕ್ಷನ್ಸ್ ಅಂತ ಬಂದಾಗ ಎರಡು ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರುತ್ತೆ. ಒಂದು ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೆಕೆಂಡ್ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಂತಂದರೆ ದಿ ಗಿವನ್ ಫಂಕ್ಷನ್ ವಿಲ್ ಬಿ ಆಫ್ ದಿಸ್ ಫಾರ್ಮ್, phi of u comma v equal to 0. Now in this case, when the given function is of the form phi of u comma v equal to 0, first thing is you have to identify u and v, which are usually functions of x and y. Usually nimge functions of x and y ne kotirtare. So identify u and v, then find the partial derivatives. Partial derivatives means u is a function in two variables x and y, means you have to differentiate partially u with respect to x and y. You get ux and uy. Similarly here you get vx and vy. Then finally use this relation, ux by uy equal to vx by vy. Now simplifying this expression, you get the partial differential equation, the required partial differential equation. Now let us discuss the problem on this. First problem I am going to consider. Form a PDE given phi of x plus y plus z comma x square plus y square minus z square equal to 0. Solution: given, see this you can write or you can calculate. Given u equal to x plus y plus z, v equal to x square plus y square minus z square. Usually we take u and v as functions of x and y, I said already. So here you have to treat z as a function of x and y. You have to treat z as a function of x and y. Now find the partial derivatives. Now ux equal to differentiating u with respect to x partially, 1 plus z. If you differentiate, you get dou z by dou x. That implies ux equal to 1 plus dou z by dou x ke ನಾವು notation ಇಟ್ಕೊಂಡಿದ್ದೀವಲ್ಲ p. Next uy equal to 1 plus, okay sorry, it will be 0 first term, 0 plus y, if you differentiate you get 1 dou z by dou y. So that implies uy equal to 1 plus q. Similarly vx first, vx differentiating v with respect to x partially, you get x square derivative is 2x minus 2z into dou z by dou x. That implies vx equal to 2 times of x minus z into p. Next there is vy. Okay, I want v 2y minus 2z into dou z by dou y. That implies vy equal to 2 times of y minus z cube. Now we have ux by uy equal to vx by vy. That relation we have to use, alva. So that implies ux ಅಂತಂದ್ರೆ 1 plus p divided by uy 1 plus q equal to vx 2 times of x minus zp divided by 2 times of y minus zq. So 2 get cancelled. If you simplify this expression, so cross multiplying this you will get y minus zq plus py minus zpq equal to, now multiplying these two terms, x minus zp into 1, so x minus zp into q plus xq minus zpq. So here zpq cancels on both sides. Then I'll get, taking terms on one side, y minus zq plus py, ಇದನ್ನ ಹಾಗೆ ಬರ್ಕೊಂಡಿದ್ದೀನಿ, ಈ ಟರ್ಮ್ಸ್ ಲೆಫ್ಟ್ ತಗೊಳ್ಳೋಣ, minus x plus zp minus xq equal to 0. So that implies y minus x, then ಇವರ ಟರ್ಮ್ ಬರ್ದಾಯಿತು, minus zq minus xq, or do one thing, here take z common in these two, plus z times p minus q, ಇದು ಒಂದು ಟರ್ಮು, plus z times p minus q, ಇವೆರಡರಲ್ಲಿ plus py minus xq equal to 0. That is the required PDE. That is the required PDE. Next, let us take one more. Problem B. Form the PDE given that phi of xy plus z square, comma x plus y plus z equal to 0. Solution. Given u equal to xy plus z square, v equal to x plus y plus z. Now differentiating u with respect to x and y partially, again I have to treat z as a function of x and y, so differentiating with respect to u and v partially, I will get ux equal to y plus 2z into dou z by dou x, y plus 2z into dou z by dou x. So that implies ux equal to y plus 2zp. Similarly, uy x plus 2z into dou z by dou y. So that implies uy equal to x plus 2z into q. Now come to v. Vx equal to 1 plus other two terms you get 0, so vx is 1. Similarly, vy also you get 1 plus, sorry I forget one more thing, dou z by dou x, 1 plus dou z by dou x. That implies vx is 1 plus p. Similarly, you can check vy will be 1 plus q. 1 plus q you get. Now using that relation, we have dou z by ux by uy equal to vx by vy. That implies ux means y plus 2zp divided by x plus 2zq equal to 1 plus p divided by 1 plus q. there is no common term to cancel out. Now cross multiply this, let's see. Y plus 2zp plus qy plus 2zpq equal to x plus 2zq plus px plus 2zpq. 2zpq cancels on both sides, so I remain with the terms on kade tagona. So let us take these terms to this side. X plus 2zq plus px minus y minus 2zp minus qy equal to 0. So that implies x minus y, this two term over 2zq plus 2zp. So if you take 2z outside, p plus q, these two terms over, remaining px minus qy equal to 0. So that is the required PDE. Next let us take one more. Problem C. F of xy divided by z comma z equal to 0. Solution. So here instead of y they have given f. So only thing is notation is different. Given u equal to xy by z, xy by z, and v equal to z alone, okay. Now differentiating u with respect to x and y partially, first I'll get ux equal to, okay, see here we treat z as a function of x and y. So numerator you have function in x, denominator you have function in x, so I have to apply quotient rule. Z square into, in the numerator, z into derivative of the numerator you get y minus xy into derivative of the denominator dou z by dou x. So that implies you get ux equal to zy minus xyp divided by z square. Similarly uy you get same thing you have to do here, z square in the numerator, z into derivative of the numerator is x minus xy times dou z by dou y. So that implies uy equal to zx minus xyq divided by z square. Now Vx equal to, you have v equal to z, differentiating that with respect to x partially, you get dou z by dou x. That is Vx equal to p and Vy equal to, similarly you can check, you get Vy equal to q. Now we have, okay, we have ux by uy equal to Vx by Vy. That implies, what is ux? Zy minus xyp divided by z square all divided by zx minus xyq divided by z square equal to p by q. So this z square get cancelled. We remain with zy minus xyp divided by zx minus xyq equal to p by q. So that implies, if you cross multiply this, zyq minus xy pq equal to pzx minus xy pq. So here minus xy pq cancels with minus xy pq. So we remain with zyq equal to pzx. So okay, you can take terms on one side. So taking pzx minus zyq equal to 0. Z common दिखे बदला. Therefore z times of px minus qy equal to 0. So that is the required PDE. So you can write like this, or product of these two will be 0, means either one of the terms should be 0. You should have px minus qy equal to 0. Enough, you can stop at this stage. Now let us take one more. Lx plus my, abc, I think it is D. Lx plus my plus nz equal to phi of x square plus y square plus z square. So this is the given function. Lx plus my plus nz equal to phi of x square plus y square plus z square. Let us do one thing. Consider the given. See, this is not of the form phi of u comma b equal to 0. It is not explicitly given in that form. Given Lx plus my plus nz equal to phi of x square plus y square plus z square. Eliminate here the function phi to get a partial differential equation. Differentiate both sides with respect to x partially. Differentiate both sides with respect to x partially. What we get? Left hand side we get L plus my will be 0 on differentiation, n into dou z by dou x equal to phi dash of x square plus y square plus z square, that into derivative of inner function 2x plus 2z into dou z by dou x. So that implies I will get L plus np equal to phi dash times L plus np equal to phi dash times 2 into x plus 2zp. Call this as equation 1. Now similarly differentiating the given expression with respect to y partially. Differentiating given equation with respect to y partially. What we will get? M plus n into dou z by dou y equal to phi dash of x square plus y square plus z square into 2y plus 2zq, or 2z into dou z by dou y. So this becomes m plus nq equal to phi dash times 2 into y plus zq. Now I want to eliminate phi dash, so dividing equation 1 by 2, or else you can divide equation 2 by 1, no problem. So that gives me L plus np divided by m plus nq equal to phi dash into numerator of equation 1, equation 1 on right hand side I have phi dash into 2 times of x plus, it is zp, right, not 2zp, x plus zp Similarly, in the denominator, phi dash into 2 times of y plus zq. So phi dash get cancel, cross multiplying this, you get L plus np times, see you can cancel 2 also, L plus np times y plus zq equal to m plus nq times x plus zp. So that implies, if you multiply corresponding terms, Ly plus Lz into q plus npy plus npzq equal to mx plus mzp plus nqx plus nqzp. nqzp cancels, so this cancels with this, so we remain with Ly minus mx. I am taking these terms to this side, Ly minus mx, so these two over Lzq ikkada nxq ide, so taking q outside, q into Lz minus nx plus, in these two taking p outside, p into ny minus mz equal to 0. So that is the required solution, the required PDE. So with this we are going to wind up problems on elimination of arbitrary functions or constants to form PDE. So in the next video we shall discuss solution of PDE by direct integration.